Okay then, folks. Thank you everyone for coming out. It's great to have a great time out this evening. Really appreciate that. Very quick bit of housekeeping from me before we get started, because we've got lots of great talks and people for you to hear from this evening. This is the AI and Deep Learning for Enterprise meetup, number 15. We are hosting talks all about applied AI. I'm very excited to have you here this evening. My name is Hugh. I'm an organizer at ADLE. We also have two other hosts this evening, which is Naomi and Tom, who are just up here at the front. If you need any help with anything, or you need someone to talk to about something at the event, with people to talk to, so please do give us a shout. One final thing, if you're looking for the loos, they are opposite the atrium. You have to go back out into the lobby area down by the lifts. Someone will be there to buzz you in and out. But without further ado, I'm going to hand over to Tom, who's going to talk to us a bit about Cisco and our speakers. We also have Ian and Peter who are speaking this evening. Ian about Llama CPP and Peter about Microsoft Copilot. So yeah, some great talks. But first things first, a bit from Tom about our speakers from Cisco.
Oh,
sorry. Yeah. Stop seeing.
To Cisco. I'm just going to give a very brief talk about AI at Cisco, basically, just to introduce roughly what we do in the space. Obviously, there's a lot more than on these slides, but I'll just give a very brief introduction to this. So yeah, my name is Tom. I'm a software engineer here at Cisco. I work in the devices technology group. So all these devices here, all these whiteboards, I work on the operating system for this and work specifically on the collaborative whiteboarding experience. So I've been part of Cisco for about 5 years, various teams since then, and this is what I'm doing now. So we have two awesome speakers today. They're not in person, they're going to join virtually. We've got Kari and Ingrid, who are going to join from the Cisco Oslo office. They both work as software engineers in the machine learning team based in Oslo. So yeah, they're going to give a talk later. So yeah, what do we do in the devices group? These are the devices you should just be able to see on the slide there. I'll just move the selfie out of the way because that's in the way now. So yeah, we create all these devices here. I specifically work on the operating system that is a variety of languages. But yeah, these are some of the devices that we make. So we make a mixture of desk devices as well as boards and big devices that we have here too. So they work for, they're obviously mainly designed for collaboration tools and work across obviously WebEx, Zoom, and Microsoft Teams and Google Meet. And if you want to find out some more information, there's a QR code just here. We do have an example of them in real life. So here's a slide of showing how some of these can be used in meeting rooms, offices, at home. So as I was saying, we have a lot of involvement in the AI sector across Cisco. I work in collaboration, so I'll give a very brief introduction to these. So we have two main kind of segments here that I'm just showing. There's the stuff in the devices and the stuff in the clients. Again, there's a QR code to find out more information. And yeah, Kari and Ingrid will go through some more details later in their presentation for some of the device intelligence that we have and some of the models that we have in devices. So that's it from me, a very brief introduction. Yeah, and that's it. Are we going to pass over to Demon now? Who are going to go through more stuff? So.
Yeah, thank you, Tom, for that good overview of Cisco. Yeah, just a bit about Demon. We are the partner sponsor for the meetup. So if you come regularly, you'll have seen me before, you'll have heard this before, but welcome to anybody that's new here. So for those of you that don't know, Demon are a technical consultancy. We have specialists in cloud, in AI data, and also in engineering. But we really are just about the culture that we've built. We really employ approachable, great people who just want to help the clients. We've worked with some really big clients as well, mostly within retail, so Sainsbury's, Walmart. We've got Conjecture within the AI sector. And we also won many awards for our best companies. option as well. We are looking to hire, so if you are looking for jobs, particularly within the mid to more senior principal levels, we've got a whole range on our website. So please scan the QR code or come and see me afterwards to find out more information about life at Demon. Thank you. Yeah, we got a bit from WeWork now as well.
Good afternoon, everyone. Good evening. Sakila Jamini here from WeWork. I'm from our business development team working in our EMEA and Asia Pacific region. I've been with the firm for 5 years. We're here as WeWork today by the lovely invitation of Mr. Evans. Thank you very much, Hugh, and the AI and DR for Enterprise team. I'm sure many of you have seen us in the news, headlines, articles as of late from WeWork. Very, very exciting times for us. I'm here today from the WeWork side to share some exciting news from our side and just share more developments of what we've been up to as of late. From our side, if we take a quick step back, what we've been looking at as a team in WeWork is essentially getting back to our core essence and what we're known for. As many of you may know, WeWork was born out of the 2008 financial crisis in New York, founded in 2010. And as many of you may know, a lot of professionals were let out of work and looking for a place to become an entrepreneur, a founder, freelance, and people looking for coffee shops, parks, and where to congregate. Enter the co-working space, helping to support all of these entrepreneurs kind of to scale the culture of co-working. Fast forward 10 years, and that WeWork has grown onto multiple countries, cities, and buildings. What we then saw as we entered to the pandemic, we've had many arguments of which industry has suffered the most out of pandemic. I would say office space and aviation are the top two. We can argue about this afterwards in networking. But what we're able to see essentially is coming out of the pandemic, VC funding, investors, private equity, and M&A activity really hit an all-time high. What we're able to see from our side is essentially all of the companies that received VC funding were coming from fintech, disruptive tech, Web3 companies that were all looking to disrupt technology at the time. And what we were able to do as WeWork is essentially become a platform to support the growth of these companies in 4 main ways: cost savings, location, programming, and scaling, quick and easy turnkey solutions. What we then did was we did a retrospective analysis and looked at all of the unicorns that were founded in this time, specifically in 2021 and 2022. Looking at here, we've got your CBank, Klarna, FTX, Fireblocks, Revolut, and in 2022, we've got Klarna, Ramp, ScaleUp, SumUp, and MoonPay, all of which have become WeWork members. And what we're able to do is essentially engage these members and say, what was it that made you come to WeWork? What was it that made you and your team grow from Series A, B, C, ultimately to even some of them going for an IPO? And what we're able to see is that these companies were able to leverage WeWork, not only for office space, but ultimately for collaboration and being in an innovative space, working alongside like-minded innovators and co-founders. So to the tail end of 2023, as VC funding has slowed down, as many of us may know, the rise of interest rates, VC funding pulling back, subsiding unfortunately, we then took a step back and re-engineered our offering and say, how best can WeWork support the next chapter of growth in disruptive tech? Enter AI, enter machine learning, and deep tech. What we then did in 2023, so towards the tail end and early in 2024, is repackage ourselves as WeWork and looking at how best we can target this next level of growth in the technological space. WeWork has now given our utmost support towards AI companies by launching this platform that we see right here, an AI offer that essentially looks to offer office space at £99, $99, 99 euros per month for AI companies. Essentially looking at how best we can allow cost savings for these companies that are growing from strength to strength. And we were able to see that our enterprise clients, which are noted on the screen here, and bringing them value and saying, if you're an enterprise client, you're most likely looking to scale, maybe you're looking to acquire, hire the next talent. Where are you going to do that? You're going to do that in a WeWork. As a scale up and a startup, what are you looking to do? You're looking to grow and commercialize your business, monetize, and actually have that runway where you're able to sell to big corporates. How are you going to do that? You're going to do that in a WeWork. So what we've done in the 3 weeks that we've launched this in 2024, we've had over 500 companies come to us, sign up, apply, and essentially submit and say, hey, WeWork, I'm interested in this. please let me know how I can be a part of the next revolution of AI and in this community that's going to be taking place. As I mentioned previously, the four main aspects why a startup or enterprise company would be looking to come to WeWork. One, turnkey solutions, being able to have a workplace or an office space that essentially you can move in from day one. Secondly, collaboration and programming, having the relevant technological themed events, VC days, pitch days, hackathons that all take place in WeWork. Thirdly, you're looking at costing, allowing companies to save up to 50% of real estate costs. And lastly, locations, being able to be in London this week at a conference, flying over to New York next week, meeting with investors, and lastly, then flying over to San Francisco and being in Silicon Valley with the relevant technological innovators there as well, all with one membership. So I implore everybody that's here today, take a snapshot of the link that's there on the screen. If you're interested, if you know any of the companies that are growing, scale-ups, enterprise companies that are interested of joining the next chapter of Revolution, WeWork is here to stay, WeWork is growing, and would love to see with you. I'm here with my colleagues. We've got Mallory, we've got David at the back. As I mentioned, my name is Sakile. Look forward to welcoming you, and let's grow. Thank you.
Cool. So for our first talk this evening, we have Ingrid and Kari from the Oslo Cisco ML team talking about how deep learning empowers video meetings.
Yes, thank you. So my name is Kari.
And hey, I'm Ingrid.
And we're going to talk about how deep learning empowers video meetings. And since Tom already has given you an introduction to our lovely video devices, we will just jump straight to the fun stuff. So both Ingrid and me, we work in the machine learning team. And we are responsible for developing the machine learning models that runs on our devices. And that includes everything from the data collection and labeling to the training, testing, evaluating the model, and also run them real time on our devices.
So which machine learning models do we actually have on our Cisco devices today? Well, let's go through some of them. We have one model for detecting heads in video meetings and one for recognizing faces in video meetings. Here you can see Kari and me in a meeting room. And when we enable a feature that's detect head, we are able to split our view in different frames like this. And this is because our heads are detected. And you can see that the view follows us. And when we put on diagnostics mode, you can see that the green boxes is detecting our heads and the white boxes around us is suggestions for frames to crop the view. Also, you can see that the face is recognized as Kari got her name label. And when I move, you can see that the green box follows me as well.
Yeah. But Ingrid, it's a bit better to have on frames, isn't it?
Yes, let's put it on.
So now you can see us more clear as well in the presentation. So we also have a background segmentation, which enables you to replace your background with a picture of your choice, as Ingrid is doing here. And we also have a gesture recognition model. So if you don't want to speak in a meeting, you can choose a hand gesture of your choice, and it will be sent as an emoji on the screen to the other participants in the call. But in this talk, we wanted to give you a more deep dive of one of our models, and that is the head detection and how it works. But a bit disclaimer is that we won't go into too much details of our models, as we don't want to reveal any company secrets, but we want to give you more an overview and try to explain the fundamentals of object detection. But what is really object detection? Well, object detection within computer vision involves identifying objects within images or videos. So instead of image classification saying whether there is a dog or a human head in the image, we identify where the human head are within a bounding box telling you the size and the location. And we are going to focus on the deep learning approaches. And within deep learning, there are two main types of detectors. We have the one stage and the two stage. And the main difference between the two is that the two stage detectors, they include this region proposal step that do the object classification for each region within the image. They're usually better at accuracy, but they are a bit slower. And as we run the models real time on our devices, we need fast detection. So we're going to focus on the one stage detectors.
And when we look at the architecture of the model, there's one important thing, and that is that we split the architecture into two main parts. We have one encoder part and one decoder part. And the encoder's job is to extract features from images. So here we have one example. This is an awesome picture of Kari and me wearing what we call fast shades in Norway. I am aware that this is not very popular to wear in the UK yet, but at least this is pretty in Norway to wear them, I swear. But anyways, if the encoders were to receive an image like this, its job would be to extract features. And by features, we mean small objects within the image. So in this example, features could be our shades, our heads, our faces, my arms, Kari's legs, or ID cards, or just a watch, for instance. But how do we extract features such as what we just saw? Well, we use deep learning, and there are many approaches within deep learning on how you can extract these images, these features. But we will focus on one of the most popular techniques, which is using convolutional neural networks. And convolutional neural networks is just a neural network that uses the mathematical operation convolution. And gladly, we will not go into how convolution works, like the math parts. Today, we are software engineers, so we skip that part. But what we want to do is to go into what or how we perform convolution. So first, we send the image into the neural network that we just call CNN. And this is the input of the CNN. And then we perform convolution by using a filter. And the filter is actually a matrix. And this matrix is trained as our model is training. So when the model is untrained, these numbers in the matrix would just be random numbers. So when we have trained our machine learning model, the numbers within this filter would be specified for extracting certain features. So how do we use this filter? We apply this filter on the image, but not on the entire image, but only part of the image. So we start by applying this filter on this part of the image. We perform convolution, and the output could look like this. And then we slide further into the image and go through the image step by step and get a new representation of the input. And this is what we call a feature map. And we have multiple filters that produces different features map. You can see that this filter focuses on different features than the other. And we can get many different feature maps just by using different filters. And when we go through multiple layers using multiple features, we will end up having a huge amount of different features, and the output could look like this. And you can see that there's many ways to represent this picture by extracting features. So that's how we use CNNs to extract features. So the output of the encoder could look like this.
Yes, and next is the decoder. So the decoder's job is to reconstruct these feature maps from the encoder and to the final output. Or simplified, it gathers information from the features or the output from the encoder and then make a prediction. And how do a decoder works? Well, it depends. There are a lot of different decoders, but to scope it down, we have chosen to focus on a very common one within object detection, which is YOLO, or you only look once. And how YOLO works. So the concept of breaking the image down to grid cells are unique in YOLO. So the decoder uses the output from the encoder, as you can see here, but to simplify and make it a bit more understandable, we will use the original image further for this explanation. So the image gets divided into n by n grid cells of equal shapes. Here in our case, n is 4. And for each object that is present in the image, one grid cell is said to be responsible for predicting that object. And that is the grid cell where the center of the object falls into, for instance, this grid cell. And the grid cell predicts a bounding box together with a probability or a confidence score telling how likely that bounding box is to contain the object. But what is really the bounding box and how did that get calculated? So here there are a lot of numbers, but I will try to scope it down. So the T's here, that is the predicted output from the model. And to calculate the bounding box X and Y, which are the center coordinates, they are calculated relative to the bounds of the grid cell. And the bounding box width and height, they are applied transformations from the anchor box dimensions, or the PV, or prior, as we also call here. But what are really an anchor box, Ingrid?
Yes. So anchor boxes are predefined boxes that is actually set by us, the developers. So what we do is that we go into our own data set and we look for what are the most common shapes of heads, and then we create some start boxes called anchor boxes that has different shapes and sizes. For instance, like these two that we use in this example. And we use these anchor boxes as starting boxes so that when the YOLO model is supposed to predict bounding boxes, it starts with some anchor boxes. They are the starting boxes. And then it's easier for the YOLO model to predict actual bounding boxes because it has something it started with. So for each grid, the YOLO model predicts heads based on the anchor boxes. So for the first prediction here, it's based on the first anchor box. So what we see here is not the anchor box, but it's the final prediction that used the first anchor box. And this prediction is represented through the vector that we see up here in the slide, with a confidence score, and X and Y representing the center of the box, a width and height. And also you see a lot of C's there. And these C's represent classes. Classes is something you can choose yourself. Which classes do you want the model to predict? For head detection, it's common to maybe use poses because that's, I guess, normal to use. Like, and by poses, we mean like what position is your face, like this. That could be classes that's used. And for the second prediction, you can see here, that's based on the other anchor box. And you can see that they are not the same shape, and that's because they use different anchor boxes as starting positions.
Yes, so what is actually happening is that the model predicts a lot of these boxes depending on how many of these predefined anchor boxes each grid cell are supposed to predict. So the next step is to apply output processing, because how do we end up with only one bounding box per object? So first, we usually filter away the boxes with a low confidence score, typically below a predefined threshold. And then we apply a technique called non-max suppression, which picks the box with the largest probability, and then uses a function called intersection over union, or Jacquard's law as it's also called. And IOU is a measure of the match between the predicted and the selected ground truth bounding box. And the higher the overlap, the better is the score. As you can see, closer to 1 is excellent. And then we do this filtering until we are left with only the best boxes. And that's how the model can locate the heads within an image. But what can we use this for, Ingrid?
Yeah, so there are many scenarios of where we can use the head detection, and we will show some of our features that we have implemented on our devices, which uses head detection. So 2 features is people focus and frames. And we have one video that we're going to show you guys, which explains how these features works.
People focus utilizes the intelligence that is built into our cameras to dynamically update the screen layout to ensure that you get the best view in a meeting, regardless of where you join from. People Focus is a layout option on your WebEx device, taking you from a traditional view like this to this, a much better experience for everyone. We are now extending this intelligence to enhance the view that remote participants get of your meeting room. And this is what you're probably used to seeing. Now, this is the view that you will get. even when joining third-party meeting platforms. WebEx by Cisco makes hybrid work more inclusive, blurring the lines between home and the office.
And we also have another kind of new feature called cross-view, where there are multiple cameras set up in the room. And for choosing the right camera, we use both the speaker track, but also the head detection and also the pose, as Ingrid talked about, where the persons are looking. And we also have a small demo for this, which we got some demo experts to make for us.
Hello, Kari. Hello, Ingrid. What we wanted to show you is a quick demonstration of cross-view. We're up on the 5th floor in River. So anyone, please feel free to come and try this out, if you have booked it, that is. But let's show you how this feature works. So let's first and foremost go into our speak track. Now, this is something we're a little bit more familiar with, where we get this nice cropping. But what's great about cross-view is when I then start to speak to Stephen, what the camera's going to do on the side is kick in and give you a much better view of what's actually happening around this table. And it's not just me who needs to speak. Obviously, Stephen's here as well.
So then when I start to speak, what will happen is the other side camera will kick in to put me into view, allowing you to follow the entire conversation on the far end, regardless of where it's happening on the table here.
And this head detection means that wherever we're in the room, the camera's going to get the best view of us possible. So when I speak to the front of the room, camera at the front, well, it's going to pick me up there as well. Hopefully this has been informative for you guys, and yeah, let us know if there's anything else we can.
Sit up there. But yeah, that was it for us. Thank you for having us.
Thank you, Kari and Ingrid. That was amazing. I think we have time for, let's say, 2 quick questions from the room. If anyone has any questions? Oh, just one over here for a second.
Is it okay?
I think so. Yeah, go for it.
Feel good.
Yeah, thank you so much for the talk. That was very interesting. There's so much happening. So YOLO V9, for example, was released very recently. I don't know, 2-3 weeks ago. There is YOLO World, which is an open vocab model. So I'm just wondering how, because open source community is just moving so fast in this direction. So how are you just staying on top of that? And because it's important, because they're really fast, they're accurate, and it's getting better and better every day. And also, so how are you just considering that in your software workflows? And the other is for open vocabulary, which is just searching for something in the video. So just writing a prompt, like who was talking the most in the meeting, or who said what? Like, do you see any applications for open vocab models in your products? Thank you.
Yeah, so the first question about the research, I guess. So we do use a lot of time on the research and try to stay on top and explore like the newest, what's out there, try to see what works for us. Like we do have some limitations, right? Since we run our models on the device, so we need to make sure that, yeah, they're not too big and we don't increase the compute. We need to share the resources with other models and also software. So there are a lot to take into account, but we're definitely using a lot of time to research and make sure, yeah, we try out what's best and newest out there. And the second question?
Yeah, if you looked into using, like, tracking the talking in meetings.
Yeah,
right?
yeah, it's basically YOLO World, which is like GPT in combination with like image. So in the image, you say, I'm looking for a goat, or basically these models are trained on some objects, but YOLO World is for what it's not been trained. It's just so good that it's seen something, and now without being trained on those, it's able to find those in the image for new stuff. And that's YOLO World. I think it was, I don't know, maybe a month ago it was released. So that's also very interesting thing that is happening in this domain. So, but potentially there could be many applications, like, things that the model was not trained on, finding those in the video. So.
Yeah, definitely. I guess I don't know what we can say, but we are exploring the possibilities of yeah, the newest as well. So yeah, looking forward to when we can share when we have something new to yeah, add on to our devices. But yeah, definitely it's a lot happening. It's happening so fast as well. So and also we have the vision transformers, right, as well. So yeah, transformers are the new thing at the moment. They are too big to be able to run on our devices, for instance, but who knows in the future. The compute power is also increasing a lot. So in 10 years, yeah, or shorter, I don't know.
Hard to say, yeah.
Great stuff. Any other questions from the room? One over here on the left.
Can you hear me? There's this device called the owl, and this seems similar. I wonder if you have compared the performance of your models to the owl. The owl is actually a physical device that you put on the table in the meeting in the meeting room, and it does similar tracking. So I wonder if you've come across it yet.
Owl, was that what you said?
Yes, owl. OWL.
Oh, yeah, I don't know what that is. Do you?
I'm not
that's
familiar with that either.
No.
But yeah, we have done lots of different performance tests on different types of models, but that's more like models we have developed ourselves that we look into how to build our best model.
Oh, this is not a model, it's an actual device that is separate from the computer. So you might look into it. It's quite interesting and related to the kind of work you're doing. So you might be interested.
Cool.
Well, thank you again to Kari and Ingrid. That's fantastic. So much for that. And now on to our next presenter of the evening, Peter.
Thank you all very much. First things first, can you hear me all right at the back? Rowan, Martin, good? Nice one. So yeah, good evening all. Thanks so much for having me. I think this is my fifth AI and deep learning event, so extra especially privileged to be joining you today and talking about Copilot for Microsoft 365. So yeah, my name is Pete. I'm a consultant for the advisory team at FSP. And as I say, for the past few months in particular, I'm spending a lot of my time with a number of different clients, both government departments, different organizations, and helping them to launch Copilot for Microsoft 365. I want to share some of those kind of key benefits, but also some of the kind of the concerns and the risks that we've encountered as kind of helping these organizations kind of grapple with. Many of them is their first foray into generative AI at scale. So certainly a less technical discussion than the previous one, but a little more kind of, sort of changing the doctrines of this tool. So before I begin, just like to start with a kind of quick overview of myself and my own kind of background and why I'm so particularly excited to be working with this technology. So I started my career in modern workplace kind of development and then moving on into consultants, mostly in the kind of the Microsoft stack. But then some years back, I moved particularly into the conversational AI space, eventually managing an agency and a product and helping lots of different organizations build and manage chatbot solutions, latterly using large language models a lot, of course. So yeah, I now work with FSP. It's a digital transformation consultancy based predominantly here in the UK. There's about 300 of us, and we have capabilities across the full spectrum of digital transformations, strategy, cloud engineering, data and AI, cyber and threat management, modern workplace, and then change and adoption. And actually, as part of our kind of Copilot rollouts and helping those organizations do tend to be kind of a lot of these capabilities. Yeah, in FSP, I work with lots of different areas, lots of different kind of projects, but given my background and where I've come from, I'm particularly excited for working with Microsoft 365. So to start with kind of a quick overview and introduction to kind of Copilot, Microsoft 365. I think, Martin, you kind of mentioned as we were chatting before, there's a wide array of different kind of Copilots, and it's actually causing quite a lot of confusion for organizations and clients. Not least also they do a number of generative AI solutions as well. So you'll be familiar with, or possibly familiar with, kind of Dynamics for 365, and that provides assistance across business functions such as sales, marketing, and supply chain. Security Copilot, of course, as you imagine, a security solution helps detect and investigate and respond to cyber threats. And of course, I imagine a number of you here are familiar with GitHub Copilot, and that obviously helps a feature of GitHub that helps developers to write code. But yeah, certainly the focus of my attentions recently and the focus of this talk would be around Copilot for Microsoft 365. Now that can become a bit of a mouthful after a while, as you can imagine. So I'll just be referring to kind of as Copilot going forward. So I hope you know what I mean. Yeah. So in a nutshell, Copilot is an AI-powered productivity tool that can help you with various different tasks across the Microsoft 365 applications and as part of your day-to-day, such as things as writing emails, kind of creating reports, scheduling meeting, and generally generating insights from across your data and across the organization data. They can really be thought about in these kind of three key components. So firstly, there's the large language model, and I won't need to tell you about this, but it's obviously the technology behind ChatGPT, and in this instance, it's GPT-4. And then Copilot uses grounding in the graph, and that's a process of connecting the large language model to your organizational data in using the Microsoft graph. So that's such as your emails, your chats, your documents, anything essentially that you have permission to access within your Microsoft 365 tenant. And what that does is provide a much more relevant and personalized suggestions based upon that context and content, and really sets itself apart from ChatGPTs and your Bards and even Copilot for Web that you saw before. The other differentiator is, of course, it's also integrated within your Microsoft 365 app. So these are the things that you're using as part of your kind of day-to-day, such as Word, PowerPoint, and Outlook and Teams. And I'll go through a few examples. Again, really the kind of combination of these three things has the potential to provide many benefits for users. And as I said, working with a lot of organizations, running through the trials, and they're really starting to kind of see these benefits. And it's things like increased productivity, so automating time-consuming tasks, enhancing creativity, so suggesting ideas, inspiring with different examples, learning support, so discovering new topics from across your data and different skills and interests, and deepening that knowledge and expertise. And then also kind of a key one is around sort of better information discovery, so better discovery of data. So understanding your natural language queries, and then retrieving back relevant information from your data sources across Microsoft 365. So yeah, a key kind of improvement on that kind of standard Microsoft 365 SharePoint search that you might be familiar with. So Word, certainly across the applications, one of the more kind of popular integrations, helping you to kind of draft documents, but not just from kind of a rough outline like you would with ChatGPT or Bard, but from kind of data in other documents, in other spreadsheets or PowerPoint. So kind of create me a report from this document and this document, and then it sort of builds out that starter food to like a 10 for you. And in Teams, and I think this is probably one of the areas that users see the most value the quickest. But it helps you catch up on meetings that you've been in or meetings that you've missed with a kind of summary of that meeting. Essentially kind of takes a transcript and allows Copilot for you to ask, Copilot allows you to ask questions of it, receive back kind of a meeting agenda or kind of key actions. And as I say, for many users, this is where they first see the greatest value. And what else we'll say is a bit of a kind of nod to the kind of previous conversation. It works very, very well if everyone's in kind of in their own individual Teams calls. When you're in a room, not quite so much, because it's all kind of going, if you turn it on, it's all going from that one computer, so it only recognises it as one user. So hopefully, this is so new, this technology, and it's improving all the time. So hopefully something they'll kind of be able to address somewhere down the line. Yeah, and in the chat function, this is kind of a central place for you to interact with Copilot and helps you to find content. You can ask things like, help me prepare for this particular meeting, tell me about a bid management process, look for this particular file and pull out themes. But then, as you'll know, we've kind of ChatGPT and Bard, so much of the kind of value is in your skills as kind of a prompt writer. And the same is true for Copilot for Microsoft 365. So rather than looking just in a file and kind of pulling out the key topics, you can say, look in this file, pull out the key points relating to senior management accountability, summarize it in an email, make it short and suitable for senior management, and it will go off and do that for you. Quickly run through these. So yeah, an Outlook, ability to kind of summarize emails you've missed if you've been off on holiday, as I was quite recently, particularly kind of useful to highlight any key important actions that you need to jump onto. And it also helps you to draft emails and provide you with coaching on how to improve your email. In PowerPoint, so you can ask it to create a presentation. Say you've written a script, you want to create a presentation off the back of it, it will go and do that and kind of pull in relevant stock imagery. Not bad if you want quite kind of a basic start to the 10. I didn't use it for these slides. It's not if you're particularly kind of design conscious or what have you, it's not going to give you very much more than a kind of starter for 10, but certainly kind of useful for the basic PowerPoint presentations. And then in Excel, it's also embedded, integrated, so it helps you to kind of analyze and explore data. So for instance, if you're asking it to kind of project the impact of a particular variable change, then generate a graph to help you visualize that, it's able to do that. Again, it's kind of very much in preview at this stage in Excel, so pretty good and pretty useful, kind of sort of quite kind of foundational users. For more kind of advanced users, they aren't kind of seeing quite the same adoption there. But I've had Copilot for probably about five months now, and I use it kind of pretty extensively, as I mentioned, in Teams, in Outlook and Word. It's great for kind of search. So very rarely do I ask someone, what's that document we're working on there, about that policy. I'll ask Copilot and it'll go in a very intuitively retrieve for me. I don't use it so much in kind of Excel and PowerPoint. But yeah, at the end of last year, Microsoft published really quite comprehensive reports on the impact Copilot was having on productivity and creativity and time saving of employees. And this was based on a survey of their early access program last year, so across sort of 100 or 200 or so kind of different organizations. And they were seeing some of the insights included like 70% of Copilot users said they're more productive. About the same said they also improved quality of work. And overall, about sort of 30% faster in a series of different tasks, such as searching, writing and summarizing. And I'd say that kind of broadly chimes with my experiences of working with lots of different organizations. But it really does depend on the kind of the role and the team and that kind of particular person as to whether they can see that these kind of benefits. But certainly by empowering employees to embrace generative AI, organizations are kind of helping to drive that innovation, but also that competitiveness. A number of my clients jumped onto Copilot because they saw that as an opportunity to kind of stay competitive. And this brings me on to sort of one of the other kind of key benefits of Copilot. Now, this is a recent study by Salesforce, and it highlights really that companies need to provide employees with a secure sandbox to explore and adopt generative AI. Otherwise, employees are just like to do it themselves and find ways that aren't properly governed by their enterprise and put their business and their IP at risk. And I think we've all heard some of the stories of kind of IP leakage into kind of publicly available foundational models. Yeah, and as such, it kind of Copilot enables employees to embrace and explore the potential of AI and generative AI, but within that kind of Microsoft 365 trust boundary. So yeah, this kind of high level architecture and kind of flow diagram, you can see it highlights that the information contained within your prompts, the data that they retrieve, the generated responses all remain within that Microsoft 365 service. Furthermore, any of this information isn't used to train foundational LLM models, and that includes those used by Microsoft themselves. However, this does kind of bring on to one of the kind of key considerations for any organization implementing Copilot, is that, see, like any kind of good AI solution, it relies heavily on the kind of quantity and the quality of the data that's available in your organization. In this instance, Microsoft 365 tenancy. So therefore, it's really important to kind of have good data management and governance strategy in place. And this is a lot of where we've helped out in the early stages of exploring Copilot. So asking yourselves questions like, do you know where your data lives? Can you identify old data? So is Copilot going to bring back stale information to my response? And then crucially, can people access sensitive data that they shouldn't? And that last one is kind of particularly of concern to companies launching Copilot. I think much when, some of you may be aware of a tool called Delve, but when that was first launched, much like that, Copilot doesn't give the user any sort of additional permissions to data, but it does make it that much easier for users to access content that's been overshared. And then Microsoft provides lots of controls around security and privacy if you manage that data. So configuring data classification and labeling, managing data access and permissions, and being sure to kind of monitor and audit data activity to kind of get in place before you start exploring Copilot as an enterprise. Similarly, I think depending on your kind of data governance posture, you want to be quite selective around the candidates that you choose for any initial trials. So yeah, on the subject of data, out of the box, Copilot is limited to the data that's within your Microsoft 365 tenancy. However, of course, most organizations will use different file stores, different tools as part of their workflow. And this potentially kind of limits the opportunities that Copilot provides across different use cases. So that's where kind of plugins and graph connectors come. And they can really be bridge the gap between Copilot's native functionalities and external data sources and third-party platforms. So yeah, graph connectors are a way to kind of bring in external data from various forms and sources into your graph. Whereas plugins are kind of extensions that enable Copilot to access your third-party apps and services. And so, for instance, this is an example. This GIF is of Jira and Jira ticket information being pulled into that conversational interface within Copilot. So I think like a really powerful opportunity to kind of take in all the different data sources that you work with during your day-to-day and have it in that kind of central kind of conversational interface. Quite exciting. So yeah, there's a number of different kind of basic technical prerequisites to consider. However, outside of your data governance setup, which I kind of touched on, deploying and activating Copilot is actually kind of relatively simple. Kind of technical prerequisites by and large the same as your Microsoft 365 apps. But to truly kind of unlock the value and realize the benefits and really kind of build trust in the tool as well, it's quite a key one. Requires quite thoughtful and responsible approach to driving adoption and proficiency amongst your users. That's true of most technologies, of course. However, Copilot and generative AI, I think, warrant its own kind of particular set of considerations. I think the other thing to kind of highlight is it's currently valued at, so user licenses are currently about $30, so £25 a month per user. So particularly if you're a big organization, it's not an insignificant investment. So you really want to make sure that you're providing it to the right employees that are going to get the most value out of it, and that they know how to kind of use it properly. So I think like many of you will be kind of familiar with the different kind of change and adoption approaches, and these topics will probably kind of be quite familiar to me. So I just wanted to add a little bit of kind of additional guidance around Copilot across these. So the first one to start with is, the working group. So I think whilst I highlighted some of the key common benefits and risks of Copilot, these definitely do differ across different organizations and different functions within organizations. Therefore, when considering your vision and your strategy for Copilot, it's definitely important to assemble a good kind of diverse and cross-functional working group. comprising different individuals of expertise in AI, in ethics, in legal, in compliance, privacy, and of course, business strategy. And this team will kind of collaborate to ensure you have kind of comprehensive coverage across your implementation and your adoption of Copilot. As I said at the beginning, for many organizations, this is their first kind of foray into generative AI. So you want representatives that are going to help create your policies and ensure that your ethical and responsible use of the technology. And also by kind of giving these tools and kind of, again, going back to the productivity gains, if you're giving them to some employees as opposed to others, that really could be perceived as providing unfair advantage. So keeping HR abreast of these changes as you go through the trial of the technologies, yeah, super important. Yeah, and I think the same comes to when you're sort of like looking at your trial groups and then hoping to build a champion network from your trial groups. You also want to draw from diverse cross-functional user base. Don't make assumptions around where Copilot might provide value and enable your team to find their use cases and then give them the opportunity to then kind of promote those use cases and those kind of different prompts that they might use as part of their day-to-day. Yeah, and that brings me on to training. So like accessing and using Copilot, and hopefully you can sort from those little GIFs, is reasonably intuitive, and Microsoft provides a wealth of training content for you to draw on. So where we're working with customers, we're very much kind of focusing on our energies on the training content around kind of building skills around prompting. Particularly for those that haven't kind of explored ChatGPT as part of their day-to-day lives. And then from that kind of drawing out their particular use cases and prompts that sort of might help them as part of their day-to-day. And then, as I said, like enabling them to then share that around their team. Yeah, and when it kind of comes to comms, looking to kind of make use of the Microsoft tools that are already available, so teams to collaborate with working groups and champions, setting up Ask Anything channels, using kind of Viva Engage, which is kind of like an internal sort of Facebook to enable users to collaboratively exchange practices and insights. And measuring success, this is quite a key one. As I say, it's quite a big sort of investment. So we do a lot of kind of user surveys to baseline where they're at and then kind of track adoption benefits. But there's also tools like Copilot Dashboard, which helps kind of track usage patterns and potential time savings and productivity gains. So yeah, just in conclusion, yeah, Microsoft 365 definitely a kind of powerful tool. Seeing a lot of kind of great adoption and some really great feedback on how much it's helping users with things like productivity and creativity. And it definitely delivers a lot of kind of benefits to organizations, the wider organization. But it does require good data readiness and governance to ensure the quality and security and compliance of generated content. And then as I kind of finished up, does require a kind of careful change and adoption strategy to ensure users understand the value, the capabilities and limitations and adopt it in a responsible and ethical way. But yeah, thank you ever so much. Highlight, we are hiring as well, and we're building our data and AI team, so we've got a few roles there. Should be interested. We do also have an upcoming event. I don't have the link to it just yet, but if you follow us on LinkedIn, we have an event in our Reading office on 6th of June.
Brilliant stuff. Thanks, Peter. Do we have any questions for the room? We have time for a couple. Someone on the left-hand side over there. See? Yeah.
I have a question about security. You might have talked about it already, or maybe I missed it. But I understand that in an organization, a large organization, some people will have access to documents and others wouldn't. But a system like this means someone can ask a question and the model will comment a document that he probably shouldn't have access to.
Yeah.
I guess in that case, you can use SSO to control their access to the document. But that's if your document is sent to them. But what if the model is just trained on information from that document? How do you control that people don't come across information that they shouldn't have otherwise had access?
Yeah, see, so Copilot will only have access to the documents that you have permissions to. But as I said, and sort of SharePoint and Microsoft 365 have lots of sort of tools that enable you to control permissions for different document information. Yeah, definitely one of the challenges is because of that natural language processing and the semantic indexing, it retrieves that information that much easier. So we spend a lot of time with organizations making sure they have kind of those permissions in place so that documents around particularly kind of sensitive areas that they shouldn't have permissions to are locked down. I would say though, actually, it's reasonably good if you just ask like what somebody paid on or give me information around the payroll. It's pretty good at saying, okay, I can't answer that.
Just one on the left over there. Oh, sorry, yeah, sorry.
The underlying model or the LLM that is powering this, I presume at the moment, since it's Microsoft with GPT 3.4, is there the capability to swap out the underlying model as required for either a kind of proprietary one that the enterprise profession tuning themselves, or kind of a third-party model? What is the kind of approach around making use of proprietary?
Yeah, not for Copilot. For Microsoft 365, it's pretty locked down to their own version. I believe it's GPT-4. I'm not sure. I think I read it in GPT-4, but it's sort of very much locked down to their own version. They don't open it up to kind of exploring integrations with other LLMs. There is a solution called Copilot Studio, which enables you to build the plugins and the graph connectors that I mentioned, but it also enables you to build bespoke Copilots for sort of narrower use cases. But again, it's using kind of the OpenAI service in Israel.
That's all the time we have questions, I'm afraid, but I have one question for Peter, which is, are you going to the pub afterwards?
I don't know if I...
Well, if Peter is coming to the pub, I'm sure to decide if you have any more questions for him, I'm sure you can catch him then. Yeah. If not, I'm assuming you're happy for you to reach out, LinkedIn.
Elsewhere. Yeah, absolutely. My QR code is here.
Oh, thanks again, Peter, for that fantastic talk. Okay then. Thank you everyone for after the break. We now have our final speaker of the evening in Oswald, who's talking about Llama CP for fun and for profit. Maybe profit. Maybe profit. Sorry. Maybe profit. Thank you, Ian. Thank you very much. Okay, it's my first time at this meetup. I'll talk about the meetup that I run in a moment. I'm curious about the makeup of this meetup. How many of you, keep your hands up, how many of you self-identify as data scientists somewhere in that data science role? This is quite different to my meetup. And how many on data engineering? Okay, more on the data eng. Analytics in general, so number analysis, stuff, a few more. And managerial side, I think that's the rest of you. Okay, so it's really, okay, it's quite a split. All right, thank you very much. I'm not sure what most of you are going to make of this talk. But I'm excited to be sharing. So who am I? I'm an interim chief data scientist. I've been in the field for 25 years. I've gone through a long career developing intellectual property in startups and then running my own consultancy, building my own startups, killing my own startups, taking some money, selling a little one along the way, learning a bit of that entrepreneurial ride, but really all the way through enjoying the process of turning raw information into something actionable. I loved writing the code to do that, and then found lots of ways that didn't work for clients because the client was not set up to turn their information into something actionable. They needed help elsewhere, and then I've ended up in the last 7 years moving into a much more strategic role. And so now I go into data science teams and I help them become more valuable. So I go in as an interim chief data scientist to help just make data science teams ship value into their organization. So I have strong opinions. To back up having strong opinions, I have to get hands-on to figure out how things work.
And alongside that, I do training. I've got a bunch of my own training courses, which I use in these teams that I help to make more valuable. And I've got a new one on fast pandas, which I was working on just this afternoon, and I'm delivering to a hedge fund in a week's time. And then I'll be opening that up. If any of you care about pandas, the few data scientists and data engineers in the room, if you care about pandas and you find it slow and frustrating, I'd love to hear why in the pub afterwards. That's why I mentioned it. I'm co-author of High Performance Python. The second edition is out at the moment. We're working on the third edition for publication next year, which is why I care about fast pandas, fast computation. And I'm a co-founder of PyData London. So I co-founded that with a couple of other people 10 years ago. We've been volunteer building that for a decade, and it's now 13,000 members. We have 100 plus people turning up at Man AHL's hedge fund over by London Bridge every month, and then we hedge the pub after. Got a lovely group of people who used to ask me, Ian, why do you spend so many years volunteering, building this meetup? And I joke, because people like me turn up and we talk and we go to the pub and we drink beer together. And then I realised after a while, that's exactly why I volunteer building this, because people like me just come to the pub with me. So come to the pub afterwards and we'll talk some more about this stuff. Right. Oh yeah, and at PyData London, we've got one of our conferences coming up this year, volunteer driven. We raise 100 grand every year for the open source community. We've been building that for 10 years alongside those monthly meetups. It's in June. We'd love for you to come along, have a look. The schedule will be up on the website soon. It's a really nice conference, very practitioner-led, very hands-on, with a beautiful audience there. So it's a really nice place to go and socialise. Why am I giving this talk today on Llama CPP, so low-level large language model interaction? It's because part of my work now is on this strategic team advisory. I go in and I help my data science teams become more valuable. And separate to that, I've set up a strategic data science leadership group for excellent data scientists who have become leaders and are suddenly struggling with shipping value, managing expectations, dealing with expectation management, whilst growing the team and tackling the right projects and prioritising appropriately. And one of the questions that comes up in our monthly meetings that I organise is management want me, the C-level board want me to use LLMs everywhere, but they're kind of rubbish, right? They don't work. How the heck am I going to do them when my data engineering isn't working yet? And I realised that I had to have a stronger opinion. So as part of that Rebel AI leadership group that I run, I decided to get a deeper opinion of Llama CPP, which is an open source large language model runner. So unlike OpenAI and ChatGPT, where you use a web interface to talk to somebody private model, like the model is not exposed to you, with Llama CPP, you download the model runner from GitHub. You download it, so you compile it with Make. 5 minutes later, you've got a working model runner on your machine, and I'll show you some demos of that running. Then you go to Hugging Face, which is the repository on the right, like a GitHub, but it's a GitHub for large language models, for deep learning models in general, but lots of LLMs. You go and download one of these models. They're 6 gigabytes or 60 gigabytes. They're pretty big. You download them, you put them on your laptop, and then you can just run them with a command line. It just runs locally, and I'll show you some demos. So that image at the top, anyone recognise which GPU that is? It's pretty topical right now. It's the NVIDIA H100, the one that only costs £30,000 and only has a 30-week lead time around it. So if you want to build up a set of those in your organisation, you need a $500 million budget and half a year to wait to establish the team around that GPU set. It'd be nice if we didn't need that kind of expensive large GPU to run our models, and indeed that's what Llama CPP gives us. It's a re-implementation of the GPU-based code that would run initially on a CPP, so a C++ based environment on our laptops, and then GPU support was added in alongside, and multi-GPU support was added alongside. Critically, nothing is sent off of your machine. And so unlike in Peter's talk, Peter was saying about organisations being wary of people bringing in external models and then exposing their data to these external models, sending the data off-site. I massively encourage you to try these external models on your laptop because nothing leaves your laptop. It's all just running off your laptop. I'll show you the demo in just a moment. If I look in the models folder. Those are a bunch of the models that I've got just on my machine locally. Wi-Fi is not running, everything's going to work just fine. So I can play with client demo data given me, or a client can use this on their laptops, on their desktops, in their organisation, trying these things out live. Why use these local models? Well, apart from the use your client data and your source code without exposing it to being trained upon by an external organization. You can experiment with the models as they're published. So as these new models are brought out into the world, which happens all the time, and it's desperately exciting, but it's happening at a crazy rate. You just download them and play with them as they come out. So let's say you want to prototype an idea. You've seen that the Llama 2 7 billion parameter model is available, and then you've got this crazy idea that you want to make a movie similarity matcher using some kind of LLM to prototype some idea. You put a question into Llama CPP, you run it, that's the main at the top there. You point it at a model, so that's the models flag, a GGUF file format, that's the format for downloading these LLM models. And then you give it a user a prompt, and it's chat with Bob. So Bob is a useful, helpful user agent who will always respond truthfully and helpfully to any query. And then you ask it a question: is Double Impact an action film or a romance film? Oh, it's an action film. On a scale of 1 to 5, on a similarity measure, how similar are these two films? And it will give you an answer. And of course, the answer is going to be pretty crap. It doesn't know a lot about movies that are out there. It was never trained to be a similarity engine, but it will give you some kind of model, some kind of answer, which is kind of interesting, kind of cool to play with. And you can see there, that's my activity monitor in the top right corner. You can see all the cores of my machine, or half the cores of my machine are running, and it's just running in the CPU mode. I'm not using the GPU in my laptop. But it runs, and you get text streaming across the screen. It's pretty quick. This, I think, to me, this is the main reason why we care about running these models locally. Separate from the idea of not exposing our client data to an external organization, which is incredibly important if you want to prototype your models and you haven't got permission to have some kind of licensed agreement with Microsoft, for example. The big thing is, all these models are a bit rubbish. They all break in various interesting ways. And if you go and use, you'll say, Ian, just go and use OpenAI, stop messing around with this open source stuff, just go and pay for ChatGPT-4, and it's great, and it's brilliant, apart from when you call it 1 million times, some of those weirdnesses will come through, or 2 million times, or 5 million. Those weirdnesses will come through, those guardrails are there, they take away more and more of the weirdness, but they cannot make it perfect, because these models, they're really clever, but they're not brilliant. They don't understand the human world. They are just next token autocompleters, and we'll see an example of that a bit later on. So there's weirdness in all of these models, and the guardrails try and patch all of that as best we can, but we can find ways through it. If you play with these models locally, you'll find things just go wrong. And that lets you sit there and think, all right, I can see the ways this kind of query on this kind of model goes wrong. So I've got to think about how I'm going to patch that, and capture that, and protect myself from that in my prototype in my organization. So here's an example with the Microsoft Phi-2 model. So Phi-2 was one of the a class of small language models that Microsoft has been releasing over the last couple of years. Super interesting papers behind it. Really, really nice model. They use ChatGPT-4 based training data without the rest of the rubbish from the internet. They have a subset of generated data, a succinct training set. They train up Phi-2. And then they say, look, with this succinct training set that's really well curated, we can ask it physics questions and it will reason its way to an answer. And then they share the answer on the website. Blimey, this thing's reasoning its way through interesting physics problems. It's kind of a teacher at that point, right? I wonder how reliable it is. And so I run the query a bunch of times and I find out, along with 28 meters per second, it's 125 meters a second or 17 or 40 or 30 or whatever. And so it makes me just a little bit suspicious about what's going on. So, which one have I got here? Well, that was I want to show you just a summarization with whose model. That's with the Phi model there, first of all. Then I'll show you that other query. So I can ask it perhaps, given this chunk of data that I've taken off of Wikipedia, identify some keywords for me. That's brilliant. It finds 5 this time. That's great. They're not keywords, but it's given me some kind of summary based on this text that I've asked it to do. That's kind of nice. I'll run it again and we'll just see if it does. It's doing a pretty good job. Sometimes it goes off or it does nothing sometimes, and other times it will go off and do some. It's doing a pretty good job this time. Sometimes it goes and does random stuff. There it was doing a pretty reasonable job. What if I decide that I want a JSON output? So I could tell it, please identify 5 important keywords in the following text. Restrict yourself to a JSON compatible output format. And often it will say, sure, I'd love to write you some JSON. Here is the JSON, followed by the JSON. So you have to strip out the preamble and then get the JSON out. One of the nice things you can do with Llama now is you can provide a grammar file. That's the last bit down at the bottom there. Provide a grammar file, and then when it's generating tokens, it restricts itself to only the token set that meets valid JSON. Something you can do with OpenAI as well, but it turns out it's something you can do with any of the language models that are available. So it's kind of cool. We can start to restrict our models to JSON and then pull out just what we want. It's harder to specify exactly the format of the JSON that you want. You can provide prompting to give it the right examples, and then it can try to give you something that fits that example. But you can at least get out something parsable at that point, rather than something you have to parse and clean up for a random open text example. Do I have... there we go. You're a helpful high school teacher. Please solve the Microsoft example from their paper. What's the key speed, slope? And then, 26 meters a second. Okay, that's not bad. And here it gives us a big derived answer. That's kind of nice. Wow, why a big answer? And if I ask that again, this time I'm just going to write a markdown version of the answer. It's just wandering off through text generation space. The answer is 8.94 at the bottom there this time. I was hoping for a Python example. Often it writes Python for me. And if I say, don't write Python, just give me an example that will be understandable by a 10-year-old, it will go off and write some Python for me. Sometimes Python works, and sometimes Python doesn't work. Sometimes it looks like brilliant Python AI, but you run it, and it's the one this afternoon, it developed a complex number and then tried to round the complex number. And so I don't know how it managed to develop a complex number in the middle of its physics, but it's a kind of really varied output. So it's kind of weird, yeah, 31.3 is the answer this time. And sometimes the derivation, all the numbers are perfect all the way through, almost as if it's memorized an answer, and then it comes up with an auto-completed number at the end, which is maybe or maybe not the answer that we see in the paper. And it just makes me a bit suspicious again. But it's kind of interesting, right? Because we can see the ways that these models are generating the next best tokens, which sound plausible, but they're just not necessarily correct, just in the real world. So how is it that we can run these very large models on a laptop in CPU mode here? And I can turn on the GPU optimization. I've got a 4 gigabyte GPU in here. So it's just a laptop with a regular GPU. It's nothing particularly powerful. At home separately, I've got £1,000 worth of an RTX 3090, so a 28 gigabyte external card with a big external box. And that box is basically a big power supply, a Thunderbolt cable, and a PCI backplane, and then you put the card into it, plug it in the side, and I can see 2 GPUs, and then I can run that bigger GPU to make these things run faster, but it's just another GPU, just a single GPU, only cost £1,000. So how is it we can run these things inside just a laptop rather than these £30,000 graphic cards, and it's through quantization? So think about JPEG compression. So you take a JPEG of a raw GIF file, an uncompressed GIF file, and you start to do a little bit of compression. You as a human can't perceive a difference in the image, but the file size goes down a lot. And then you do heavy compression, and you can see blobs of color floating around in these really grainy areas. And then that's the heavy compression giving us a tiny file size. We see a similar thing with quantization. We can find these model weights, which are floating point numbers spanning perhaps a float 32 range to a 4-byte range, times billions of parameters. And then we can do things like truncate them, or just cut them from float 32 down to float 16 or float 8, and then just start truncating, moving the distribution around. But it turns out there's all sorts of interesting properties with the rare, massive positive and negative outliers, where if you truncate them or shrink them in, they lose the signal that they're encoding, which empowers the answers inside the machine. So when you're doing this compression, you have to start compressing by remapping the dynamic range of each of those parameter sets, so that when you just shrink in that distribution, you're actually maintaining all of the necessary information from the outliers through to all of the majority of the data, which is in the center of that distribution. So there's a whole fascinating field that's really quite intriguing around this quantization process. But it means we can compress from 32 bits to 16 to 8, 7, 6, 5, 4, 3, 2, and then down to, at the moment, 1.5 is the optimal minimal number of bits to represent these parameters. And Microsoft put a couple of papers out a few weeks ago showing that you can not only quantize a trained model down to that, but you can even train in 1.5 bit space rather than in 32-bit space, which is massive. It opens up both speed advantages, advantage for putting in more data into these models and running them on more conventional graphic cards. So there's some really interesting things going on out there. And this is one of these beautiful outputs. This came from one of the Llama CPP pull requests, talking about, well, we've developed this new quantization process, and then people saying, well, but how do we know it works, right? What's going to happen when we quantize these models? We compress them, we're losing information. It's not going to give us the answers that we want. And so somebody put some graphs together. That black circular kind of banana-shaped plot at the top there, the black square point, that one there, that's I think that's Llama 7 billion, so Llama 2, 7 billion parameters. Float 16, so 2 bytes worth of information. The model size is on the x-axis, so that's about 10, 20 gigabytes model size, and perplexity is a measure of when the model generates its output, when it's making its predictions as to the next word, whether it's producing words or tokens that it thinks make sense, they match its training distribution, or whether it's going off on kind of crazy paths and throwing out things that maybe don't make quite so much sense. You want a lower perplexity. When perplexity gets bigger, then the model's starting to do some random crazy things. And what they could show was, you take the floating point 16, the 2-byte representation, you cut it down to 1 byte, and the perplexity does not change. You don't lose any information in the model, at least as best as we can measure it at the moment. But the model size goes down by half. Brilliant. And then you go from maybe that was sort of 10 bits or 8 bits, you go to 765. You begin to lose some perplexity, not a huge amount, but the model size carries on decreasing. So that's kind of interesting too. But then you go to the next model up, the red one, the 13 billion parameter model, and you go from 16-bit representation to 8-bit, you lose no perplexity. You start trading off bits, and it gets worse and worse and worse. This red line comes up and up and up. But you end up with this 7 gigabyte model whose perplexity is always better than the previous model, even when it was uncompressed. It's got a better perplexity than the black line there, the 7 billion parameter model. And then we can see that for the 7, the 13, the 30 billion, and the 65 billion parameter model down here. So that 65 billion one, you go from hundreds of gigabytes down to about 30 gigabytes, and its perplexity is still always better than the previous best model set. So that's kind of interesting. You can compress these huge models down to this smaller set, and then you don't trade off the intelligence or the knowledge that's been stored inside this model. I say intelligence, I do not mean intelligence, just the knowledge, the language modeling knowledge that's in there. And that's 6 months old. There have been new quantization processes in the meantime, so we get better compression. It's happening like on a weekly basis. It's dizzying trying to follow it. What about image queries? Text is kind of interesting. ChatGPT gives us multimodal queries, so we can query images. Can we do that with open source? Yeah, sure we can. So, where's my? There we go. So here I'm going to use the Lava model, which is Lava 1.5 from just before Christmas. Open this up, browser. So now I get an interface where I can give it an image. I'm going to give it an image. Oops. So this image comes from a charity card drive that I did last year. I'm just going to ask it to describe what's in the image. Return. So there's the car. I'll show you that. You should see there's the CPU running in the background. So this was a car that I drove last September, raising money for Parkinson's research. It was Parkinson's last year. Driving from London to Venice and back in a week, 24-year-old car costing under £1,000. We spent £650 on this Passat estate, and it was going to be amazing. And after £2,000 worth of repairs, we had a car that passed its MOT and was going to go and do the run, and it did its run to Venice and back. We've now done another chunk of repairs ready for this year's run. We'll be raising money for Alzheimer's this year. And we had surfboards on the car. And I thought, hey, there's no way the Lava model has seen a Volkswagen Passat with surfboards on top of it. So it's never seen this. This is a novel image. It's never been in its training set. So we can ask it about it. So I can ask it what's in the image, and what does it see? Well, there's a white car in front of the car. In front of the car, there are two surfboards. So ask it what's sure. There are 5 individuals. Sometimes it says 5, sometimes 3. It's actually 3. It's describing where the people are. That's kind of nice. The presence of multiple surfboards suggests they might be enjoying a day at the beach together. It's not true. It's a charity run driving through Europe with no beaches in sight. But hey, it wouldn't know that, right? It was a pretty good guess as to describing what's in that image. And that's just running on the CPU on my laptop. What's unusual in the car? There's a car with surfboards. This is unusual because it's not common for people to drive cars with surfboards on top of them. No, it's true. It was quite unusual driving that across the Alps, popping out of a minor access road at the base of the snow-covered mountains, wearing our tiki costumes. But we raised good money for it, so it was a nice thing to do. Let's kill that. So. These are some of the other queries that I asked. What is the car? So it's never been trained explicitly. These images are about Volkswagens. These images are about Fords. Instead, it will be given text describing what's in an image, and it may or may not describe the car that happens to be in an image. But it's able to pick up on the logo describing what this vehicle is, so it knows that it's a Volkswagen. Normally, it's a Volkswagen car, sometimes a van, sometimes various other things. How many surfboards? Normally 2, sometimes 3. But it doesn't know what a surfboard is, and they shouldn't be strapped to an estate car, but it can answer that query. What colour is the car? Well, it's saturated. It's calling it white, not grey. That's not unreasonable. What is the number plate? Well, it comes up with a pretty close approximation. It's wrong. S61 UKM versus S65 UKM, and sometimes it comes up with very different answers, but it's normally not a million miles away. And it was never trained to be an OCR engine. It was certainly never trained to read number plates on cars. On the front image of an easily taken image of a car in a parking lot outside of a French hotel at the start of a charity run, but it does a passable job at it. So if you wanted to use this as a way to enrich images and experiment with those ideas locally, you can download Llama CPP, 5 minutes, you type make, it compiles it up, you download one of these models, and then you start pushing your images into it, start pushing your client images into it. And this was in my mind because I worked with insurance companies some of the time, and so thinking about claims management systems and checking images that are being uploaded and checking that they meet certain requirements. You can get specialized systems that are always way better than any of these generalized systems, but you can't then just play with a novel idea when you've got a novel idea because you can't get the specialized system. Here you can play with a bunch of these ideas and just check that generally, yeah, this thing kind of works. We should invest some more time in it. So brilliant. Can it help with coding? So yeah, I mean, these models, of course, they can, and we see GitHub Copilot. Hands up, who uses GitHub Copilot or an equivalent code assistant? Yeah. How many of you love it? How many of you will be upset if it's taken away from you? I will not put my hand up to this. Okay, so, all right, and I'll be interesting to hear that in the pub afterwards if you share an anecdote. The reason I asked that is, okay, I'm 25 years in my domain, I've written a book on high performance computing, I'm on the 3rd edition now. When I go and do my benchmarking and I'm typing away and I'm typing in my notebook, I'm putting some benchmark numbers in, and then Copilot tries to complete my benchmark numbers for me, but it hasn't run the code. And then it explains afterwards why that benchmark number has occurred. And sometimes I stop and think, my goodness, I did not know that pandas did that. I've read the source code, why didn't I know that? And a moment later, I stop and think, you're lying to me again. That's what you're doing at GitHub Copilot. Stop lying to me. Some of the time it writes code, which makes me go faster. It's true. A lot of the time it writes code that I ignore because it's clearly not doing the right thing. Sometimes it writes code that looks brilliant, but then doesn't execute, and I have to stop and debug it, and that's really annoying. So it's that crazy enthusiastic intern who's just clipping over their own feet a bunch of the time, and I find it kind of frustrating. But I choose to pay for it because it's clearly the direction of travel, and I want to get a better opinion on it. But wouldn't it be nice if we could experiment with some of these things locally? So you can use the Code Llama model as one of the examples. This was a Coda 2, or another update just came out in the last week. Code Llama was, as of me writing this slide, which was maybe 8 weeks ago, the one that was competitive with GPT-4. I believe others are now a bit better again. But you can just download this and run it. In my experiments, Personally, unlike Peter's talk earlier, talking about using the Microsoft Copilot assistants in a generative fashion to write emails, write agendas, and the like, and to summarize, I would agree with summarization. I find using these LLMs to describe, summarize, extract some knowledge, that's one thing they do a reasonable job at. Using them to generate some novel content, that's where they just tend to get quite wobbly. They say they'll do it and they have a good crack. I can ask CodeLlama to write me a stock prediction process in Python. It'll happily kick out some code. And sometimes I sit back and think, I didn't know that stats method. I go look it up. It's a good stats method. And find that's interesting, but the code's never going to do anything useful. It has no way of telling me that's a silly question and you shouldn't ask me to write a stock predictor process. It will always give us an answer. So here I found it kind of useful, taking a function that by eye, this is a scikit-learn test function in the unit test suite. I was using this in my software engineering class in a hedge fund recently as one of the examples, talking about good quality tests that we can have and why in the hedge fund they should think about writing good quality tests from the quants down, not just from the dev people writing tests on the quant signals that have been developed, trying to change a culture internally, which was successful to some degree, I hope. But we were looking at some of these test functions from scikit-learn as examples of test functions, and it's easy to find functions which are just hard to understand. So I can ask CodeLlama, look, can you explain it? And it gives me a truthful explanation as to what's going on. Copilot, of course, can do the same, but here I can do it without sharing any of my client data off to the cloud. So maybe I can get my hedge fund clients to sit there and then use these models internally on a 10 grand GPU, nothing too crazy, to summarize their internal code bases without leaking anything which might be used for IP training. And one thing I've been playing with this is a novel mental exploration. Can I take a code base like pandas, check the code coverage for areas that are more weakly covered than other areas in the test set, and then ask some probing questions. I found this really hard to ask good probing questions at CodeLlama. Is this a good test? Is it doing the right thing? Does it have too many magic numbers? Is it understandable? Does it cover the API? And then get it to propose new example tests, which I could then run automatically. And I've had some experimentation there. And I think that might be a way just to let the machine just labor in the background all night long, trying to generate tests. And maybe in the morning it comes up with something that's worthy of my time to review. Maybe, I don't know. But it's an interesting thought experiment. The last thing I want to show you is that I think these models enable us to get really behind the scenes, get under the covers of these things and understand how they're actually working. So here I'm using the Python API. So rather than downloading the GitHub source code and doing a make to build it locally, here I do pip install llama-cpp Python. It's do a pip install, and it just installs it. It builds the local model for you, does everything for you, and then you just open up IPython and you can start querying the model. So then I can tell it to instantiate a llama model, and here I'm just pointing at llama 7b. I'm ignoring a bunch of the other parameters that I could set, like temperature and other things. And then I'm saying, right, let's make an LLM query instantiation. I'm going to give you a question, name the planets in the solar system, and then you'll note Q:, name the planets in the solar system, A:, and then fill in the blank. And so then we're forcing these tokens through the model to saying, look, these are the tokens that we're setting you up with, setting up that initial context, and then A, over to you, and then it carries on generating the remaining tokens, giving us the answer. Oh, great. I get the answer that I would expect, but it turns out I can dig into the perplexities behind this, the log probabilities behind these answers to really get a better idea as to what's going on. And I'll show you that in a moment. One thing we can also do is get some embeddings out. So the embeddings, because hey, playing with embeddings is always fun. Yeah, I'm just going to, in my IPython shell, I'll just kill that one up. In my IPython shell, I'm going to instantiate that llama model. I'm going to ask it to, embedding so they're on screen. So I ask the llama model, given these two strings, AI and DS, building opportunity, artificial intelligence and data science are generators for growth. So similar strings, but dissimilar spellings of representation. Create two embeddings. I can look at the embedding, and then I'll get a bunch of numbers. I can ask it how long that is. It's 4,000 items long, each of those vectors. I turn them into a NumPy array. and then I can pass that into the cosine distance measure, distance not similarity measure from SciPy, and it tells me that on a scale of 0 the same to 1 massively dissimilar, they are very similar strings. So I get a nice context-aware embedding similarity measure. So, okay, you don't want to build a RAG system out of that. You don't have to write all code around that, but you can start playing with this with those embeddings. So building up an embedding system to play with within a couple of lines of code, which I think is kind of cool. Right, final bit, leading to understanding. I take my LLM model. I'm curious about how these tokens are generated on the inside. I know multiple tokens are being generated, only one is selected by the sampling process, but I don't know what that mechanism is. And it turns out I can say to it, well, tell me the 5 examples, the top 5 examples you get for every token you generate. When you generate 10 tokens, behind the scenes, it's generating 10 times 5, so 50 tokens, and each way it goes along, it's generating a new set of 5. And they look like this thing down here. And then I'm curious about, what has this model been trained on? What does the canonical training set look like? What if I just ask it the question, space, see what it comes up with next? Because maybe it's going to reveal the questions that came from its training set. And if I set the temperature to 0, then it's going to represent the answers as closely as it can to its training set, rather than having a more diverse sampling process. So it's going to end up coming up with a predictive token output that looks like what went in originally. Doesn't guarantee you're extracting the information that went in the training process, but it'll be very similar. So I ask it that question, and then it starts to spit out some answers. So I get, for the first bit, a number closer to 0 has a higher probability, it's log probabilities. A bigger negative number is a number that's further away from 1 and closer to 0 in probability space. So probability 1 will have log prob 0, and a probability of 0 will have log prob of minus massively huge, possibly infinite number. So the more negative they become, the less likely they are. We start with Q, the model knows that. It tries to predict the next token it would expect to see. And it says, well, a colon is very likely 0, so P1 effectively. But it could be a 1 or a semicolon or a space. But I'm forcing it to take that colon. What comes after that colon? Well, it could be let or what or suppose or cal or s or space. And I'm forcing it to be a space. And then after that, given that it's a space, what else could it be? And it comes up with an answer like this. So I ask it the choices, and it says, oh, well, the question is 10234 in base 5 to base 16. So it's the example of the training data being forced into it, and it's being forced to replicate an answer on the other side of it. So I'm beginning to expose what's going on in the machine, which is kind of interesting. But if you think about these token sets here, it was expecting after a Q colon space to have a let or a what or a suppose, and then it's got S. It could be S, and I ask it, well, okay, Q colon space S, then what? And it goes S solve, S split, suggest. Okay, right. S event. What's S event? The completion of
17.
17, right, 17 milliliters as part of a bigger system, and then there's a question behind it. What about SQ? Square. But why wouldn't it be SQUAR? Because it could be SQRT or SQR or square. So it's representing the base tokens behind here. So here I get to see the tokens that are behind it and the probabilities behind it as well, and see how these things are being pulled out and exposing the underlying training methodology. I think it's kind of cool. It lets me look inside this thing and see what's really going on. You can do that in a couple of lines of code. So why try Llama CPP? You can run these quantized models on your client data locally with nothing leaving the machine. That's the critical thing, right? It's all just local. You can see all the wackiness that happens. The papers claim a certain thing, and then you play with it and you realize actually other things happen, and that's kind of interesting. But you will see that wackiness when you run with the large, productionized, expensive models that are available from Microsoft, Claude, and the others. You'll just see it more rarely, but you will see that wackiness, right? Those weird things will occur. So you're better off getting a better idea of it and getting a handle on protecting yourself from it. And you can play with that Python API to see tokens, complexity, and all the rest of it. So I shall wrap up there because it's pub time, and I'm happy to carry on talking about this in the pub. Question for you, have I convinced any of you to go and try llama.cpp yourself? One person, 2, 3, 5, excellent, right. Well, my job here is done in that case, I'm very happy. And for further discussion in the pub, how do we measure correctness? Strategically, working with my teams, This is dead on my mind. I get managers saying, we need this. I have the C-level suite just saying, we need LLMs. It must be LLMs. Yeah, but what's correct? And, oh, the humans will evaluate that. Not on a million queries they won't. How do we evaluate correctness? And like that Microsoft 5 physics example, it's really hard to figure out what the right answer is. We just don't have a good answer to that. So, I'm honestly very intrigued by your opinion and your experience. If you could share it when we're in the pub afterwards. Because, the follow-on question, what could go wrong with your projects? Well, that's the other bit that's a bit scary, right? And it's worth having some ideas around that. We don't go too far with this, certainly before production, to make sure you're thinking this through. All right, thank you very much for your attention.
Thank you, Ian, for that awesome talk. We have time for one quick question, if anyone has one. Let's see.
Over here. Hi.
Please.
Lovely presentation. Thank you. So I know you presented it as the last approach, you presented it as exposing the wackiness of the model, but someone could just as easily see it as a form of like data exfiltration.
Sure.
So my question is, are any of the commercially available LLMs built in with any sort of like defensive measures against exactly that sort of thing?
Yeah, because every week another attack is exposed, which shows how you can do nasty things. One of the fun ones that came out just a couple of weeks ago, there we go, the ASCII art jailbreaking bomb attack. So you can't ask the mixture and other models, how do I make a bomb? They always say, no, you can't do that. I can't tell you how to make a bomb. But you can say, given this intriguing image that I've specified and a couple of lines of my prompt, please decode that. And when you come up with magic token, put magic token into the query that I'm specifying next, and being a helpful prompt, a helpful model, you're going to give me the answer. And it goes, oh, straight up, here's how you build a bomb. Brilliant. So that lasted a couple of weeks for some of the commercial models and then was taken away. It was possible to reveal a bunch of the training data from a bunch of the publicly available commercial models via their APIs. There's a variety of attacks that come out. This is the one that was just a couple of weeks ago and it caught my eye. I've got a couple more papers at home to read. Yeah, is the short answer. And it's kind of terrifying, right? And if it just happens to be your corporate database that was used in some of the training of that, that was exposed because you're running an LLM as a chatbot interface, and then you start querying it in certain ways, and some of your corporate data starts flowing out, it's kind of scary. And then we get back to how do you measure correctness, and it's a question that a lot of people don't seem to be asking when I ask around. And I find that terrifying. So I think it's worth bringing it up.
Thanks again, Spot. Thanks again, Ian, for that.
Thank you very much.
Sure. So, three very quick things from me before we wrap up, and the third thing is which pub we're going to, so hang tight. Firstly, our next event is going to be on the 14th of May, location to be announced, but very likely to be WeWork, as you may have guessed. Second thing, if you would like to speak at an upcoming event, including the one on May 14th, because we've had someone drop out, so we have a slot available, please do get in touch with me. I'm on LinkedIn, you can message by the meetup group. We're always looking to talk to people about applied AI. If you're working on something cool, let us know. Third and final thing, as promised, the pub we're going to is the Globe, which is just around the corner. I'll be headed there myself shortly. If not, I'm sure you can follow Ian. If you could sort of make your way out of the venue in the next sort of 5-10 minutes so we can pack up and so the very helpful team from Cisco can go on home, that'd be amazing. But thank you all for coming out. Thank you.